Dear students, welcome to HomeLearns classes. In this class, I will solve for you the all sums of exercise 3.2 trigonometric functions. Let's start. Question number 1 to 5. These states that find the values of other 5 trigonometric functions. There are 6 trigonometric functions: sine, cos, tangent, cotangent, secant, and cosecant. Here you have given the value of 1 and you have to find out the value of all other trigonometric functions. Now, question number 1 state cos x is equal to minus 1 by 2 and it lies in third quadrant. It lies in third quadrant. This is the first, this is second, this is third, this is fourth. Here cos axis lies. By default, it is negative. Negative. So as we know that cos x is minus 2, therefore secant x is equal to 1 by cos x is equal to 1 divided by minus 1 by 2 and it becomes minus 2. Secant is minus 2. Why it is minus 2? Because it is in quadrant third. Now we have an identity. Let's solve it for this sine. Now let's calculate the sine. Sine square x. Sine square x is 1 minus cos square x and it is 1 minus 1 by 2 square and it is equal to 1 minus 1 by 4 and it is equal to 3 by 4 and it is equal to 3 by 4 and sine x is equal to root 3 by 4 and it would be both positive or negative. But because it is in third quadrant, so in the third quadrant, sine is also negative. Sine is negative in third quadrant. Hence, sine x is equal to minus root 3 by 4. Or in simply you can calculate more, root 3 divided by 2. That is the answer for sine x. Now this is the sine x value. This is value for secant x. We can calculate tangent x also. Tangent x is sine x divided by cos x. Here sine x is root 3 by 2. Cos x is minus 1 by 2. Minus to minus cancel. Root 3 by 2, 2 and 2 by 1 and 1 and it comes out to be root 3. In third quadrant, it is root 3 and we know that in the third quadrant, tangent and cotangent are positive. Hence, it's positive. And cotangent x is equal to 1 by tangent x 1 by root 3. It is cotangent. Now cosecant. Cosecant x is 1 by sin x 1 by minus root 3 by 2 and minus 2 by root 3. This is the value of minus root 2 by 3 because it is again negative in third quadrant, then the value would be negative. So here I'm writing down all the values of this cos x is minus 2, cos x is minus 2, cos x is minus 2, secant x is minus 2, sin x is minus root 3 by 2, cosecant is minus 2 by root 3, tangent x is root 3 and cotangent x is plus 1 by root 3. Okay. Tangent and cotangent will be positive in third quadrant. Let's move to second question. Sin x is equal, it's very easy. Sin x is 3 by 5. X lies in second quadrant. X lies in this second quadrant. As we know that in the second quadrant, sine and cosecant are positive, all others are negative. Sin x is 3 by 5, then cosecant x is 1 by sin x from the trigonometric function, 1 by 3 by 5, and it's 5 by 3. Cosecant is 5 by 3. Sin square plus cos square x is equal to 1. Sin square is given 3 by 5 square plus cos square x is equal to 1. By simplification, 1 minus 9 by 25, 16 by 25, and cos x is 4 by 5. 16 by 25 and it becomes 4 by 5. Here it comes 4 by 5 as a positive, but positive and negative both. But we know that in the second quadrant, cos is negative, hence its value would be 4 by 5. And because cos is 5 by 5, secant is 1 upon cos x is equal to 1 up 4 by 5 and it's 5 by 4. So we have sine, cosecant, cos and secant. Now we can calculate tangent is equal to sin x the cos x. Sin x is 5 by 3, 3 by 5. Cos x is minus 4 by 5. It comes out to be 3 by 5 into 5 by 4, and sign will be of minus, and minus 5 to 5 cancel, minus 3 by 4 is the tangent, and cotangent x is 1 upon tangent x. 1 oblique minus 3 by 4 or minus 4 by 3. So in nutshell, we can solve this. Sine is given 3 by 5, cosecant would be 5 by 3, and both would be positive. Cos x, secant x. Cos x is minus 4 by 5, secant x would be minus 5 by 4. Tangent x is minus 3 by 4, and cotangent x is minus 4 by 3. That's all about question number 2. Now question number 3. In the third quadrant, first, second, third. In the third quadrant, cot x is 4 by 3. As we know that in the third quadrant, tangent and cotangent both are positive. Both are positive. So if cotangent is 4 by 3, tangent x is 1 by cot x is equal to 1 by 4 by 3, and it's 3 by 4. Tangent and cotangent, we have two values. Now, we know that there is trigonometric identity. 1 plus tangent square x is equal to secant square x. 1 plus 3 by 4 square is equal to secant square x. 1 plus 9 by 16 is equal to secant square x, and secant square x is 25 by 16, and secant x is 25 by 16 root, and it becomes 5 by 4. 5 by 4 is both positive and negative, and in this case it would be minus 5 by 4, because in third quadrant secant is negative, and cos is 1 by secant x, 1 by minus 5 by 4, and it is minus 4 by 5. Secant, cosecant, tangent, cotangent. If you have tangent and cos, then you can calculate sin x. If you have cos, then also you can calculate sin x with both the tangent x is equal to sin x divided by cos x. We have, and according to this, sin x would be 10x into cos x. 10x is 3 by 4. Cos x is minus 4 by 5. It comes out to be minus 3 by 5. And cosecant x is minus 5 by 3. So we have all the values. Sin x minus 3 by 5. Cosecant x minus 5 by 3. Cos x secant x minus 4 by 5 minus 5 by 4. Tangent x Cotangent is given 4 by 3 and it is 3 by 4. This is the answer for question number 3. That's very simple. If you have learned the formulas related to trigonometric functions and the trigonometric identities, then it's very easy to prove. And one thing you have always to keep in mind, that the quadrant values of each and every. Again, I am repeating here that in the first quadrant, all functions sine, cos, tangent, cotangent, secant and cosecant are positive. In the second, only sine and cosecant. In the third, tangent and cotangent. In the fourth, secant and cosecant. And else all are the negative. Now secant x lies in fourth quadrant. In the fourth quadrant, secant x is positive, hence cos x will also be positive. Cos x is 1 upon secant x, 1 oblique 13 by 5, or it's 5 by 13. So from the trigonometric identities sin square x, cos square x is equal to 1, we can calculate sin x. Sin square x 5 by 13 square is equal to 1, and sin x is equal to 1 minus 25 by 169, and it comes out to be 144 divided by 169 and 12 by 13. That is the plus minus 12 by 13 plus minus. But because it is in fourth quadrant, and in fourth quadrant sine is negative, hence sin x would be minus 12 by 13, and cosecant is 1 upon sine. It means it would be minus 13 by 12. Tangent is sine upon cos. So sine is 12 by 13 and cos is 5 by 13. Minus 12 by 13 into 13 by 5 and minus 12 by 5. And cotangent would be minus 5 by 12. So values of all sin x, cosecant x. Sin x is minus 12 by 13, cosecant x is minus 13 by 12, cos x is equal to 5 by 13, and secant x is given 13 by 5. Tangent x is minus 12 by 5 and cotangent x is minus 5 by 12. That's all about question number 4. Now the question number 5. Tangent x is minus 5 by 12. X lies in second quadrant. In the second quadrant, tangent is negative. Only sine and cosecant are positive. Then if tangent, then cotangent is 1 upon tangent. 1 divided by minus 5 by 12, and it would be minus 12 by 5. Tangent and cotangent are given. Tangent, then what we would which identity we will apply here? 1 plus tangent square x is secant square x. Okay. Tangent is given minus 5 by 12 secant square x 1 plus 25 by 114 secant square x and 169 divided by 144 secant square x, and secant x is root 169 by 144 positive negative 13 by 12 positive negative. Because it is in second quadrant, hence secant would be negative, and if secant is, then reverse of secant is cosecant. Cos theta, cos x minus 12 by 13. Tangent, cotangent, secant, cos. Now sine, what would be the sine? Cotangent and tangent are cos and tangent are given, then tangent x is sin x upon cos x. Sin x is tangent x into cos x. Tangent x is minus 5 by 12 and cos x is minus 12 by 13. 12 to 12 cancel, 5 by 13. It means it is in second quadrant, hence sin x would be 13, cosecant x would be 13 by 5. That's all about question number 5. It would be positive because it is in second quadrant. Now, question number 6. We have given the angle sine. So find out the value of these trigonometric function. So sine 765 degree. We know that sine x repeats after an interval of 2n, or we can say 360 degree. 360 degree. Hence, we can write this as sine 765 degree is equal to sine 2 into 360 degree plus 45 degree. We can write like this. It becomes sine 45 degree, and sine 45 degree is root 1 by 2. So that it repeats after 2n or after 360 degree. Then sine 45 degree. Sine 45 degree is 1 by root 2. Next is cosecant minus 1410. As we know that sin x repeats after an interval of 2n. Therefore, cosecant minus 1410 degree is equal to cosecant is 4 into 360 degree minus 410 degree, and cosecant is 1440 minus 1410, and its cosecant 30 degree. That means value is 2. Cosecant 30 degree is value of cosecant 30 degree is 2. Now next question is tangent 19 pi by 3. Again we know that value of tangent x repeats after n, or after 180 degree. It repeats after 180 degree. Then tangent 19 pi by 3 we can written as 180 degree. Tangent 6 1 by 3 pi, and it can be written as 6 pi plus pi by 3, and it is tangent pi by 3. The tangent 6 pi, it is 0. Pi by 3, and its tangent 60 degree, and tangent 60 degree is root 3. Again, sine minus 11 pi by 3. Again, it is fact that sine repeats itself after an interval of 2n or 360 degree. Sine minus 11 pi by 3 sine 2 into 2 pi minus 11 pi divided by 3, or sine is pi by 3 with the simplification, and it becomes sine 60 degree, and at sine pi by 3 it's root 3 by 2. Cot minus 15 pi by 4, it repeats after an interval of n, that is 180 degree. Cot, we can write it as 15 pi by 4, or it is 4 pi by 4 for 45 degree, and it's equivalent to 1. That's all about the solutions of exercise 3.2. Keep watching HomeLearns. Ask any questions to the related topic by commenting on our videos. Thank you.